1687 saw the publication of Newton's massive scientific text, Philosophiae Naturalis Principia Mathematica, or Mathematical Principles of Natural Philosophy. In it, Newton included 4 laws, and armed with those 4 laws, physicists can understand and predict a large number of physical processes. 3 of those laws were Newton's laws of motion. The 4th was the law that described gravity. As the story goes, Newton was sitting under a tree when an apple fell on his head. And Newton was tempted to understand the force that made this apple fall onto his head. While this story may not be true, the force certainly is. Newton recognized that this force not only made apples fall to the ground, but it also kept the moon in orbit. And so, Newton said that every object in the universe tracks every other object with a force which for any 2 bodies is proportional to the mass of each body, and varies inversely as a square of the distance between them. With that simple statement, you could calculate the path of a baseball as it soared into the bleachers, or you could calculate the path of our Earth as it orbited the Sun. That one elegant statement sums up the motion of the moons, planets, stars, galaxies, and everything in the cosmos. Now you might wonder how a falling apple is controlled by the same force as a revolving moon. Well, in Principia, Newton explained to us how this might be the case. Imagine a cannon mounted on top of a very high mountain. If we shoot a cannonball, it will move forward, but it eventually falls down. The whole time, it follows a curve through the sky. Now if we shoot the cannonball a little faster, it will go further, but it will eventually curve back onto the Earth. We can keep increasing the speed, and at some point, the cannonball would be moving so fast that even if it curves downward, it doesn't land, because the Earth is also curved. The ball's path will keep curving, but so does the Earth, and the cannonball is trapped in a perpetual cycle around the Earth, so it is put into orbit. Now, if we ignore the fact that Newton's cannon is a bit too powerful to be made by humans, and the fact that Newton's mountain is bigger than any existing mountain, we see that gravity is actually responsible for keeping the moon in orbit. This same logic can be extended to the Earth's orbit around the Sun, or even the Sun's orbit around the center of our galaxy. Newton's insightful gravitational formula is one of the most powerful formulas in physics, and it can be used to mathematically prove Kepler's laws of planetary motion. Unfortunately, just like in the case of the second law of motion, relativity is more accurate than this law, and Newton's law of gravitation can only be used as an approximation. And so, by publishing the laws of motion and gravity, Newton concluded the scientific revolution, and with that, ended a 150-year-long period of questioning the ancients.